Welcome back. This will be video 3 as we continue our video set on helping to get ready for our final exam. We're going to begin our work on Unit 8 with annuities and sinking funds. The formulas are pretty ugly in this section, so make sure you have good access to that. I think I'm going to send you a formula sheet that you can have everything that you need centralized for your preparation for the final exam. So I'll send more information on that as we get ready. But let's go ahead and share the visualizer and look at some solutions as we move through our work on Unit 8. All right, first problem from Unit 8 is number 11. He wants to know how much he has to invest today. So we're looking for a present value. So you see your formula there dealing with ordinary annuities to let you calculate present value. The most significant things are to play around with your interest charges. All right, so in the context of this problem, that's 10% annually. So I is just 0.10. And N, since we're compounding annually, is 8 years times once per year, or just 8 compoundings, if you will. So there's your ugly looking formula. So your next line to plug in, you're going to put $20,000 in. Okay. I'm sorry, you're going to want to pull $20,000 each of those years. And your interest is at 0.10 and your N value is at 8. 1 plus 0.10, if you will, is just 1.10. Again, play carefully with your calculator as you run through these things, and you will find that if he wants to set up that annuity that would allow him to pull out $20,000 each year for 8 years, he would have to invest today $106,698.52. That is the present value for that annuity that would span 8 years and allow him to pull out $20,000 for each of those 8 years. Problem 11 is done in the books. Let's move to 12. Now you have to be careful in 12 because what's going to happen is he wants to set up an annuity. All right. He wants to find out how much does he have to put in there today to drive an annuity that is going to actually kick in at a time in the future. Okay. So if you read through problem 12 critically, he's going to make deposits of $2,000 semi-annually, pays 4% interest compounded semi-annually. And then after 5 years, he does nothing. He just lets that money sit. And then the question is, what would be the balance in his account 10 years after he made his last deposit? So we will be finding a future value, all right, and the future value for this annuity. And you're running it out for 4% compounding semi-annually. So that's the 0.04 divided by 2. So it's 2% each compounding period. 5 years, twice per year, 2 compounding periods per year makes N 10. All right, and the payment, $2,000 for each of the payments, and the payment is occurring twice a year. So you're going to go ahead and run your values in. Again, I can't overemphasize this. You don't want to round until the end. So even though I know that's very ugly to look at as you're calculating, your final answer for that future value is $21,899.44. So you're going to let that money sit then for 10 years. All right. So the problem says after that 10 years, how much would be in his account? So as we move to the second part of this problem, the $21,899.44 serves as a one-time investment, if you will, a present value, and then that's going to sit for 10 years. So we haven't changed anything on the interest compounding, so it's still semi-annually, and it's still compounded at a rate of 4% semi-annually. So you're going to go ahead and run that same action as you get ready for your N and T. All right, so 0.02 referencing the interest per period. And if you're going to let that sit for 10 years, 2 compounding periods per year, that's 20 compounding periods. So guess what? The $21,899.44 over that 10-year span grows and develops into a total of $32,541.42. And that would be the amount that would be left there at the end of that 10-year interval. All right, so that's our final answer for number 12. As we move to 13, it's important to realize this problem's got 2 questions for us to contemplate. First question says, let's go ahead and figure out how much it takes to set up that annuity. All right, so the guy decides at some point in the future, He wants to be able to pull out $30,000 a year for a span of 25 years. He's got an interest rate of 9%. Okay, so we'll find a present value for that annuity. All right, so you see the little question mark number one. That would be how much is the present value that would drive that annuity that will allow him to pull $30,000 every year for a span of 25 years. So your payment amount is that $30,000 he hopes for every year. And again, it's a very ugly plug-in. All right, your interest charge or your interest rate is 9%, 0.09, 25 years. We're compounding annually, so there's no quarterly or semi-annually going on here. So again, a lot of ugly. Let your calculator take some time. If you're into the calculator on Desmos, it might be easier to use because you can see what you're keying in. I would invite you to check out desmos.com and use their scientific calculator there because you can actually see what you're entering. But anyway, to set up that annuity, it will take $294,677.39. So you have basically found the value that answers question number one. How much does that annuity have as a present value? Now the second is, how much should he invest right now in a one-time investment, not an annuity here, a single investment, so that at the end of that 15 years before he's set to retire, he would have been able to accumulate that 294, 677 kind of number. So now you're back to your compounding interest formula. Your future value is the 294, 677, 39. You're solving for P. How much is his present value? How much must he invest today? And you've got 0.09 for interest rate and your 15 years before he wants to set up his retirement. So again, this is a little cleaner to look at to calculate. There's not quite as much ugly on that formula. Calculator runs for $80,900.15. So to set up that annuity today, he should invest $80,900.15. And at the end of that 15-year interval, he is set to be able to withdraw $30,000 each year for a span of 25 years. And that is our final set solution for problem 13. Let's go to 14. 14 is a sinking fund payment. So the FVOA is the future value of an ordinary annuity. In that case, it's the $100,000 that they're going to need. The values for I, 8% compounded quarterly, so that's 2% per period. And the number of periods would be 10 years times 4, or 40. So you're just plugging in values. Your I is 0.02. Your N is the number of compounding periods. That's your 40. So not quite as ugly a formula. You go ahead and calculate, and each period, they're going to have $1,655.57 is what they'll have to pay into the fund for each of the periods, so that at the end of that 10-year interval, they would be able to accumulate $100,000, and that's it. That's all we got going on in 14. So our sinking fund payment, $1,655.57. Solution ends on 14. All right, problem 15 is an annuity due problem. So be careful as you read this thing. Make sure you process whether it's an ordinary annuity or an annuity due. So you're going to have to take a good critical look at the verbiage before you get too confused. My paper's stacked out here. All right. The beginning of each period, that's your tip off to annuity due. It's not at the end of a period, it's at the beginning of a period. All right, so $800 is going to be invested quarterly at 6% compounded quarterly. So we're looking for a future value on this annuity due. All right, so 800 is your payment amount. The I value is the 6% cut by 4 at 0.015. Number of compounding periods, again, it's quarterly, so 4 for N, 8 years, so 32 compounding periods. Don't lose that last player, the 1 plus I, coming in as a result of the formula for annuity due. Once you get all the numbers plugged in, it's not too bad. All right, so the annuity due will have a future value of $33,038.89, and that would be the value of that annuity due. at the end of the 8-year period. So that's our solution for 15. One more as we finish out the unit for unit 8, and that is problem number 16. And this is similar to a problem we did previously where there are two unknowns. One is going to be to set up the annuity to determine the present value of that annuity. This person wants to retire in 8 years, wants to be able to take out $50,000 a year for a span of 20 years. 5% is the interest rate compounded annually. So first of all, that first question mark would be the present value of that annuity, right? I at 0.08, I'm sorry, 0.05, and at 20. Straight plug-in line. Again, it's ugly. Maybe the Desmos calculator again makes it a little easier for you. So the present value of that annuity to drive that set of payments for 20 years would take $623,110.52. Remember that we're finding out how much now has to be invested right at this instant so that after 8 years, that's how much money we would have accumulated to drive our annuity. So let's go ahead and find the answer to question 2 on to the next page of solutions. All right, so we need 623,110.52. So that number serves as A. We'll be solving for P, how much must be invested currently, so that at 5% per year after 8 years, we would have had enough to drive that annuity that would have needed 623,110.52. Straight calculations with your calculator and you solve for P. So here's the deal. You're going to have to today deposit $421,745.73 so that after that 8-year period, your annuity is set to fire and good to go. So our final answer, how much should you invest today to set up that annuity? $421,745.73. We're going to shut down our video. We'll be back in a minute with a video for the content from Unit 9. See you then.